Welcome, everyone. So glad to have you all here joining us. My name is Erin, and I'm the Student Recruitment Officer at the UBC Engineering Vancouver campus. I'd like to start by acknowledging that UBC Vancouver is located on the traditional, ancestral, and unceded territory of the Musqueam people. And I'm also joined by my colleague, Marie Reed, who is an advisor at the UBC Okanagan campus, as well as a current student, Mega, who are both located at the Okanagan campus on the traditional, ancestral, and unceded territory of the Syilx Okanagan Nation and their people. So today we are going to be starting our presentation talking all about what the difference between engineering and science is. So we get this question all the time about what's the difference, what should you know about the difference between the two. And so that's where we're going to dive in today, and we have so much information to share with you. We'll also have some time at the end to answer all of your questions as well. So to start off with, as a real kind of basic, those of you that are in high school currently, your high school classes likely have a lot of science courses included in them, but not as many engineering courses. So many of you may be taking some version of the courses listed here. But I want to know, what other STEM courses does your school offer? So those of you that are here today, you can use the chat and you can type in right now. So this is a practice basically, to type in and share with us what sort of other STEM courses that your school might offer. And so STEM just stands for science, technology, engineering, and math. So we just want to hear from you what other courses maybe you're taking, or maybe you've heard of at your high school, or maybe you're planning to take in the future. Now, science and engineering are probably more integrated than you think. And even though we are listing specifically science courses here, you'll actually take a lot of these courses in engineering, but they'll be in a more hands-on and problem-solving context. All right, so I see some suggestions coming in. So earth and space science at your school, that's exciting. Computer science as well, definitely. Those are a lot of courses that we offer in engineering will be similar to some of those. Awesome. Does anyone else have any other STEM courses offered at their high school other than kind of what's listed on the screen? Feel free to share it in the chat. So you might actually be surprised to see that your first year courses in UBC Engineering don't look that different from what you might have done in high school. In your first year, you really need that solid foundation of science theories and fundamentals so that you can continue to apply this knowledge in order to solve problems. You'll learn concepts to help you design solutions in the future. What will be most important from someone that's maybe in a science degree compared to engineering is that your introduction to engineering courses, which are AppSci 171 and 169 at the Okanagan campus, or AppSci 100 and 101 at the Vancouver campus, are actually project-based courses where you get to start doing hands-on learning right from the very start. So Mega is here with us, and she's going to share a little bit more about her experience with those engineering design courses from the Okanagan campus, and maybe a little bit about how it's different from some of the science courses that you've taken.
Yeah, thank you, Erin. So before I introduce those courses, I'll give a quick introduction of myself. I am a third-year mechanical engineering student here at the UBC Okanagan campus. I've also been I'm a transfer student from science from Vancouver campus, so I've kind of had experiences on both campuses and both sides of science and engineering. So when it comes to the design courses in engineering, I definitely agree with what Erin said, is that both first year and science and engineering have a lot of your basic courses like calculus and chemistry and physics. But the one course that stood out to me when I transferred into engineering was AppSci 171, which was the engineering drawing and CAD/CAM. The way I can explain this course is we are all surrounded by 3D objects all the time. For example, my pencil case is a nice rectangular shape, but taking that 3D object and putting it on a 2D computer screen really forces you to start thinking in a different way. And that's what this course is about. The picture on the left is actually my group's final SolidWorks project. where we designed a military submarine. It was a lot of hard work and time, but it was something that we're really proud of at the end of the day. Another project component of the same course is you get to do a 3D printing design project where you're actually tackling a real world problem. So previous topics have been designing something that helps elderly in their day-to-day life, or this year, I believe it's detection for wildfires. Similarly, Apply 169 is also a design course, but this focuses more on the sustainable portion. Past years, they've focused on the water crisis, and you're actually able to take your final project and enter it into the Aqua Hacking Challenge. The group you see here on the right, they actually won the Aqua Hacking Challenge last year. They created a mobile gravity assisted filtration bag, which is super cool. But this program isn't just about designing either. You also learn about project management skills, such as cost calculations and risk analysis and etc. Anyways, I could talk about these courses for a few hours, but I hope I gave you kind of a small understanding on how your first year engineering course could look like and how much of a hands-on approach is involved compared to science courses. Yeah, so you may be thinking, well, Mega, I like both science and engineering aspects. So the good news is that they're very interconnected. I had done 2 years of science before I switched into engineering. And if you asked me a few years ago, I probably would have said, oh, I wasted 2 years. But recently, as I go further into my engineering degree, I realize how much of a unique perspective that gives me because I see so much overlap in these two degrees. For example, I took a human physiology course where we're taught how changes in pressure helps your heart move blood around your body. And I'm sure some of you learned that in your biology courses in high school. Now I'm learning in my fluid mechanics course how mechanical pumps use similar concepts to operate. So you realize that a lot of the engineering systems are actually modeled after biological systems. And so right now I decided that I would want to do my 4th year as a biomedical option with mechanical engineering. And that's because I'm curious on how you can use engineering mechanisms and incorporate those into biological systems to make them better. And so that's something I'm excited about. And hopefully in the future, once I graduate, I get a chance to work in the biomedical industry. And that's a little bit about me.
Awesome. Thank you so much. And we'll have Megha sticking around to jump in a little bit later in the presentation, as well as to answer some of your questions for her later on. So talking a little bit more about what a degree in science or what a degree in engineering will look like is what we're going to focus on next. So a lot of students that I talk with in high school don't really know the difference between science and engineering in terms of what a university degree looks like. And many students may actually start in science with the intention of doing engineering work without having realized what that actually means. While we may see this as a common trend sometimes, it can actually get complicated. So that's part of what our presentation here today is hopefully going to help you decide whether engineering or science is going to be your best fit. So you can go straight into the program that is going to be the best for you and help you achieve your goals. Now, when we talk more about a degree in science, it's going to center a little bit more on the life, natural, and or the physical sciences with a focus on attaining fundamental knowledge about a subject through empirical and often quantitative methods. How that differs from a degree in engineering is that an engineer's goal isn't really to discover new scientific principles by observing phenomena, but rather to apply the principles attained through scientific research to solve real-world problems. Now, again, another question for you. So using the chat, you can open your chat and type in the responses to this question. What are some things that an engineer has done that may have impacted your life? So again, you can use the chat to share the ways that engineers maybe have created, innovated, or designed something that you use every day. think about the objects around you and maybe what was created by an engineer. For me, I'm thankful for the engineers that have helped design our technology so I can use my phone to navigate through the city I live in, because otherwise I'd probably get quite lost. And also for the engineers that have made life-saving advances in the medical field, so developing new vaccines, prevention and treatment of concussions, and so much more. Couple of suggestions in the chat are designing bridges into the city. Yes, that's a great option. I'm currently in downtown Vancouver, and I basically need to take a bridge to get anywhere in or out of downtown. So that's a great example. The computer that you're using right now, yes, of course, the technology that we're bringing this to you on, not just the computer, but the communication system. So the internet that we're using to broadcast this to you and everything like that, definitely engineers had a part in. Awesome, thanks for sharing that. So your first degree in something like engineering or science is usually called a bachelor's degree. This means it's a 4-year program and usually the first degree that you might obtain in post-secondary or in your university career. When deciding between science and engineering, you should also consider if you would want to go to graduate school to gain a master's or a PhD. So these usually mean that you would take 2 to 5 years of school after your first 4-year degree. So it's extending your degree by a bit in order to further specialize in your field of study. Now, both engineering and science students can benefit from having an advanced degree, such as a master's degree or a doctorate. However, one of the kind of main differences might be that in some science-focused occupations, a graduate degree is not necessarily just a valuable aid to career advancement or to specialized management roles, but it might actually be seen as a requirement for even entry-level positions. Engineering is what's called a professional degree, and it can be completed in 4 years with no graduate school needed in order to go and work in the workforce and to progress throughout your career as well. With a solid foundation, engineering can also open doors to graduate studies, law, medicine, and so much more. So that's, again, another consideration when you're thinking about your future and what you want to do.
Thanks, Erin. So now I'm going to just chat about how engineering can really set you up for success in your career, as Erin has shared all the amazing opportunities that are available to you as a student. So engineering provides a solid education in problem solving, analysis, and the application of knowledge. So no matter what you want to do in the future, you have a great foundation to continue in engineering or whatever else you're interested in. Another great attribute is lifelong learning. So engineers are improving the world around us, and to do so, they need to keep contributing to their knowledge and applying that knowledge to solve new problems. Our students, alumni, and professors are continuing to showcase the impact they can make on the world through their research and actions, like providing solutions of clean water to Indigenous populations in Canada, reducing food insecurity, making an impact on pollution and air quality, preventing and treating concussions, creating new medical devices, and so much more. Engineering is also a very well-paying job. And a new study by Statistics Canada published in 2020 shows the most top earning graduates come from engineering disciplines when comparing bachelor degrees in Canada. When adjusted for age, institution, and graduation year, the median earnings for engineering degrees in the top 30 were between $70,000 and $120,000 for both men and women. I also wanted to point out that out of the top 10, engineering accounts for 7 of the top paying jobs for women. UBC Engineering is working to reach gender parity in engineering. Increasing underrepresented populations in engineering makes our teams more diverse, and more diverse teams means our students are better able to solve problems for the entire population and not just a fraction of it. So really the point of what we're talking about today is engineering versus science, and how are these interconnected? How do you decide which path is right for you? So we've had some great examples from Mega from her experience, but we wanted to give you 2 more examples to kind of describe the difference between what a scientist would do and what an engineer would do. So the first one is environmental. So we're trying to talk about the difference between an environmental scientist and what an environmental engineer would be doing. So a bachelor's degree in environmental science or comparable subject is required if you're interested in becoming an environmental scientist. Environmental scientists use their skills to determine whether people or areas are at risk of being contaminated by pollution, as well as how to prevent soil contamination or other environmental issues. Since environmental scientists must assess data to make conclusions or recommendations, the data they collect needs to be thorough. So while they spend much of their time in labs, they may also work outside at the locations that are being assessed. The work of environmental engineers involves assessing how communities perform tasks, for instance, recycling, and then developing strategies to improve the process with the primary objective of preventing or reducing environmental damage. Another example may include creating and implementing strategies to reduce and eliminate water pollution. They may spend some of their time working in offices, but they also may spend time working outdoors. A bachelor's degree in environmental engineering or a related engineering discipline, such as civil engineering, is required. So now I'd like to go into a more specific example that kind of really lays out what environmental scientist and what environmental engineer would be doing. So in this example, Rezu WaterNet looked at the community health challenges of a small, rural, and Indigenous communities in Canada. So many communities were lacking clean water and had been under boil water advisory for years and years. So scientists and researchers collected samples of the water, and in those samples, they found high levels of natural organic matter, which can affect the quality of the drinking water as it can be toxic and harmful. So once the engineers were provided with the data, analysis, and recommendations by the scientists, they're able to begin using this knowledge and using their knowledge of engineering and environmental science in order to apply it toward a plan and a solution. So engineers develop the technology that will effectively filter the water. So in this case, they created an innovative solution to fully filter the water contained in a system that was only the size of a fridge. This is such an amazing accomplishment when you consider that most water treatment plants require very large systems that are not sustainable in very small communities with only a few homes. So once engineers create this technology, it needs to be robustly tested, and this is where the science work in the lab comes into play. The engineers and scientists will work together to ensure the technology used in the water filtration is working properly. And the last step is for the engineers to implement the water filtration technology in the community. And again, the water needs to be sampled to ensure it's working properly. So it can be clearly seen that even though environmental scientists and engineers will support different aspects of a project, they are very interconnected and they rely on each other in order to see the whole picture of the project. So next, I'm going to be talking about computer science versus computer engineering. So computer scientists or computer science will focus mostly on troubleshooting issues on a software level. So if you're interested in computer science, you would expect to learn different programming languages, how to work with operating systems, and how to maintain databases. For computer engineering, this focuses on solving problems and designing hardware and software interfaces. So for an example that kind of shows the difference, let's consider what it would be like to create a new version of the iPhone. So Apple employs both computer scientists and computer engineers to design iPhones. So a computer engineer and electrical engineers design the chips that house the integrated circuits that make the iPhone's various components function. And they figure out how to get these components to work together. So this involves looking at both the microscopic and integrated systems. Computer scientists write the operating systems that manage the memory and concurrently running applications, the apps in the App Store that run on top of that operating system, the packing and unpacking of data into packets for network communication, and the encrypting of data so that prying eyes can't see it. Computer scientists provide the glue that turn the computer engineer's beginning product into the end product, which is the device on which people text, browse the web, and play Angry Birds. From this example, it is easy to imagine, with so much dependent on each other's functions for realizing a finished product, why there is such a significant overlap in the coursework computer engineers and computer science take, and the career opportunities that they pursue. So now we kind of want to transition into the types of engineering that is offered at UBC. So before we get into that, we just wanted to mention that UBC has 2 campuses that both offer engineering programs. There's the Okanagan campus, which is in Kelowna, and the Vancouver campus, which is in Vancouver. So as Megan mentioned earlier, she has experience at both of these campuses. So I'm going to turn it over to her to share her favorite experiences from when she's been at either campus.
Thank you. Yeah, I enjoyed my time at both campuses. As you can see from the picture, UBC has no lack of beautiful scenery to put their campuses on. For Okanagan campus, it is much smaller than the Vancouver campus, which is nice because you're not running from one class to another. And you also have more of that community feel. You're closer to your professors. Vancouver campus has a lot of beautiful gardens. You're surrounded by the ocean. And if you ever get a chance to go there, I suggest that you go to the Blue Chip in the Nest and get a marble cookie. It's a must try. But more on the engineering side too, if you're looking for a more of a design team experience and a variety of those, Vancouver has a wide variety of design teams. But if you are looking for more research and more kind of that personal and closer communication with your professors, in my personal opinion, that would be the Okanagan campus. But overall, both campuses are a great choice.
Awesome. Thank you so much for sharing your experience with both campuses. There are lots of opportunities at both campuses. And one of the next things that we're going to talk a little bit about what those programs are that are offered at both campuses, because that's also part of the difference as far as which programs in engineering you can take. So the UBC Okanagan campus in Kelowna offers 4 engineering specializations: civil, electrical, mechanical, and manufacturing. There's also options that you can do within these programs. So Megha is doing the biomedical option. So there's additional ways to customize your degree. And we've talked about that in other online presentations. You can definitely check out those other presentations for more detail. The Vancouver campus, as mentioned, is the larger campus, and it has 14 different programs to choose from. Regardless of which campus you start at, you'll complete our foundational first year before specializing in your engineering program in year 2. So you don't have to know which program that you're going to pursue just yet, but we do recommend starting at whichever campus you plan to graduate from. So there are lots of options available to you, regardless of which campus you might choose, regardless of which degree you might choose. And we know that we've provided you with a lot of information today. There is much more information that can be found on our websites on this slide. So if you'd like to explore any of our websites, we also have a great YouTube channel called Engineering Stories that showcases the current life, day in the life, and what current engineering students at the Vancouver campus kind of do, what their classes are like, and what living on campus is like. So I encourage you to check that out. You'll also see Marie's email as well as my email on the screen. So if you do have any further questions about the Okanagan campus, you can contact Marie, or about the Vancouver campus, you can contact me. So thank you everyone for joining this evening.